Hey guys, in this video, I will discuss the IIT JAM 2019 physics paper from question number 26 to question number 30. I have already discussed the questions from 1 to 25 in my previous videos. You can check it out by clicking on the I button above, and I have also uploaded the official answer key which has been published by IIT on my channel. You can also visit that. So let's start this video. So this is question number 26. In this we have been asked that for a forward biased p-n junction we have to tell the which of the energy band diagram is correct for the forward biased p-n junction. So let's see what happen in for when the p-n junction diode is forward bias. When a p-n junction diode when the p junction of the diode is connected to the positive terminal of the battery and n side is connected to the negative terminal of the battery, then the p-n junction diode is said to be forward bias, and in that the potential barrier decreases and the majority charge carrier can easily move from one side to another. If we go by that condition, we will see that option A is the correct option, and we should also see that why other what other options that were given to us depicts. So option B depicts the band structure when the p-n junction is at equilibrium, since here the Fermi energy level is same for the p side and n side of the junction. And in C and option D in C and D, in both these options the Fermi energy level is depicted wrong. See, in this side the Fermi level of p side is depicted here, and in this side the Fermi level of n is depicted here. So in both the options the Fermi level itself is given wrong, and B is the case of equilibrium. So option A will be the right option. Now moving towards question number 27. In this question, it was asked the maximum number of intensity minima that can be observed in a Fraunhofer diffraction pattern of a single slit. We have been given the width of the single slit, that is 10 micrometer, and which is we have been given the wavelength of the laser beam, that is 0.630 micrometer, and we have been asked the maximum number of intensity maximum depth can be observed. So let's solve this question in notebook. So let's see the solution of question 27. So in this first write what we have been given in the problem. We have been given the slit width, that is 10 micrometer, and we have been provided with the wavelength of laser light with which the slit is illuminated, that is 0.630 micrometer. Since this is a case of Fraunhofer single slit diffraction, and we have to find the um, maximum number of sorry maximum number of minima. We have to find the maximum number of minima. Okay, so the condition for minima in the case of Fraunhofer single slit diffraction is b sine theta is equal to m lambda. So that is the condition for minima, and we have to find m, that is we have to find. So the expression of m will become b sine theta upon lambda. And since we have to find the maximum number of minima, so for that theta will be maximum, that will be theta will be 90 degree, and for that sine theta will be 1, value of sine theta will be 1, and we get the expression of m as b over lambda. Putting the values of b and lambda respectively, we will get 0.630 into 10 to the power minus 6. This thing will cancel out and we will get 15.87. And since considering our option, the most appropriate option will be 15, and that will be the right answer. So for question number 27, the correct option was D. And now moving towards the question number 28. In this, we have been asked that during free expansion of an ideal gas under adiabatic condition, the internal energy of the gas. So for this question, the correct option will be D. Let's see in the copy how this will be the answer. Let's solve question 28. So in this, we have been given an ideal gas whose free expansion takes place, and we have been asked what will be, and the process is adiabatic, and we have been asked what will happen to internal energy of the gas. Okay, so if we apply first law of thermodynamics to this, that is dq is equal to du plus pdv, that is work done. Since the process is adiabatic, so no heat will be transferred, so dq will be 0. And since free expansion is taking place, work done will also be 0, so du will be 0. That will mean that internal energy will be constant. So that's how I have told the answer, that the internal energy of the gas will remain constant. So for question number 28, the correct option will be D. As in this question, some students have some confusion. So let me also refer to give you a reference what I have told you. So let me show you that. This thing I have taken from the MIT site. You can also visit that and see it yourself. Let's see in this question. Oh, sorry. In this article, it was explained about free expansion. So let me show you what I have told you. Okay, yeah. During free expansion, there is no work exchange with the surrounding because there is no motion of the boundaries. So I have also told you that there will be no work done. Work done will be 0, and there is no heat exchange because the process is adiabatic. So according to the first law tells that the internal energy is constant. So internal energy will be constant according to first law. So I think now that there will be no doubt among you guys. If still you have any problem, you can comment in the comment section below. So now moving towards question number 29. In this, we have provided that there is a red star whose radius is r subscript capital R and temperature subscript capital R, and a white star having r subscript W and a temperature T subscript W, and both the star radiate same total power. And if these star radiate at perfect black bodies, then we have been provided with the 4 options. So let's I tell you what will be the correct option. The correct option will be the C, that is the temperature of white star will be greater than temperature of red star, and the radius of red star will be greater than radius of white star. So as in this question also there is a lot of confusion. Some of students are also, some of the student also is saying that in this question the option B and C should both be the right answer, but let me show you that only according to me only option C will be right. Okay, see, I have taken this article from the net. So in this article you can see that uh, stars whose temperature is cooler have energy that is radiated in the red tones of the electromagnetic spectrum, while those with hotter temperatures had energy that is radiated in the blue and white tones of the electromagnetic color spectrum. So by that argument, the temperature of, in our question, the temperature of white star will be greater than temperature of red star. So from this we can conclude that this argument become true, that temperature of white star will be greater than temperature of red star. Now coming to the radius thing, since both the stars are radiating as a black body, and both are radiating total power. So now let's see how to apply Stephen's law in that question, that we'll see in notebook. So let's just apply the Stephen's law for question number 29. So according to Stephen's law, power radiated is equal to area into sigma t to the power 4, and since area is directly proportional to radius square of the radius, and t to the power 4, so according to that, for red star, since the power radiated by both the red star and white star is same, it will be radius of red star to the square into temperature of r square, red star to the power 4 is equal to radius of white star to the square tw to the power 4. Since we have seen from the previous argument that the temperature of white star should be greater than temperature of red star, that we have seen from the previous argument. So if we have known that temperature of white star should be known, so for this equation should be to hold true, radius of red star will be greater than radius of white star. So by that argument, only option C will be the correct option. Now moving towards question number 30, in which we have been given a phase diagram of a pure substance, and we have to recognize what these regions first, second, third and fourth represent. So for that I have taken a slide from web. So from that let's understand. So for a pure substance, the phase diagram looks something like this. So this is the region, and this is the region in which the substance is solid, and this is the region in which the substance is liquid. This is the region in this the substance is vapor, and this is the region for the in the substance will be like gaseous region. And if and this is the region of if the pressure is greater than the triple point pressure, then solid will convert into liquid, and if the pressure is less than the triple point pressure, then the substance will directly convert into gas. Similarly, this is the line of vaporization. This is known as vaporization line. This is known as vaporization line. So something like this is the phase diagram of a pure substance. So if we match our our options according to the slide that we have saw, so for that region 4 was solid, region 4 was solid, region 3rd was liquid, region 1st was gas. So option B will be correct. Region 1 is gas, region 2nd is vapor, region 3rd is liquid, and region 4 is solid. That's perfect. So for this option B will be the correct option. So that's all for this video, guys. If you have liked this video, give it a thumbs up, share it with your friends, and subscribe the channel for future updates. Thank you.